I'm gonna go ahead and continue on. So this one here, we're dealing with jumps and stuff like that. And I'm almost thinking that okay, so in this level, tasked with implementing function calls, returning call. So I know how the return, or I mean, I know how the jump works. That's what I was figuring is they're gonna want me to essentially somehow store whatever line I'm in, so I can jump back to it. So let's see here. When returning from a function, you should jump to the address after. Yeah, that's normal. Call instruction has to do with the following. So if I call, add the instruction to the add the instruction width to the counter value and push it to the stack. And then jump. So basically, we have to put something in the stack and then jump. And then when we do our return, pop the return from stack and jump to it. Pass information to and from a function by saving data registers normal. Also be aware of which registers the function will overwrite before calling it. All right, so budget cuts have led to cutting salaries, but now the lab assistants are on strike. You will have to self-assess in this test. This test tells something about your honesty and maturity. Okay, so that's I had a feeling it's gonna be like that because if I in a program, just for the sake of argument, let me do this. Let me grab my call from the last level. Or let me grab my program, I should say, from the last level. All right, so this one here is going to be interesting because well, upstairs. Come on, click on that. There you go. Input is giving me off and on, off and on. And it's just doing that. Back and forth, back and forth, back and forth. Which is also interesting. That's a loop function. Oh, every time I do a loop, it's pushing a 0 out, which I'm not reading. So, what I was afraid of was I think Oh man, this is gonna be the fun little challenge slash change here. And that is that well, this little push stack thing here, you know, when it was initially designed, it was designed to read the input, you know, because that's what the last program wanted. And it was looking, you know, but now I'm wondering if I should be pushing or looking at the purple here, you know, for my 0. The issue with that, well, I mean, in theory, it would still work because I would call right. So here's the way we test this out. We break this here and essentially put U here. Now, oh wait, hold on. Wait a second. I haven't had to use the byte shifter at all. All right, so the byte shifter, it was designed like so. All right, so let's break that there. All right. Where in the world is it getting that loop from? Because that doesn't push data out. Well, yeah, so I don't understand how it's getting dependency. Well, okay, so actually, so I do see something. Just as default, by default, we are pushing a 0 over this line. Yeah, I get that. and that there. Oh, it's okay. It's talking about circle dependency on this. Yeah, so I'm gonna have to figure out a man. Yeah. So let me look at my numbers here. So 13. Well, it's a combination of 24, 13. But oops. So 13 feeds this stack. So I think it's going to be 13 is the universal for feeding a stack. I think I'm going to need to do 14 and 15 for outputting a stack on a given line. Yeah. That's what's causing the actual circle dependency, as it were. All right, so I'm gonna. This is just gonna get uglier and uglier and uglier. But I can tap into. Man. Yeah, the clean design is getting uglier and uglier every new thing they want me to do. All right, so let's do this. Let's try to compress the circuit some, as it were. I should go ahead and move this up, move that up. But I've got to get this one portion working first before, I mean, I got to get a rework done before we actually start to try anything new. Oops. Right. So as much as I would like to make these in line with one another, Well, technically, no. All right, so don't need that there. Excuse me. So we can just tap into it here. All right, so my output, I'm thinking about just having the output tapping directly onto this here. With a series of switches. So let's go ahead and grab, copy this. And put one there. And put one there, I guess. So, all right, so 14 will be stack to arg1 release, and then 15 will be stack to argument 2's release as far as the pathing is concerned. Okay, I can go ahead and get rid of this. All right, so actually, you know what? That's actually going to be messy. Let's see. I move this up. That's fine. That'll give me room to throw these up here. And we're gonna shift these over some. All right, so this dude's gonna come here, come around down to here and over. All right, so this here is going to be 14, and this will be 14, and then this will be 15 and 15. The thing is, these switches are not going to be tied to one another. Actually, do I need? Yeah. Well, because I'm only ever going to release once from the stack. I mean, you know, technically up here, I could have done with just a single row. Just, if I always used argument 1 for the push on that, but screw it. You know what? Damn it. Cut that off. Go ahead and put this down here. All right, because we'll run that down there. All right, so for the switches, green ties into purple. So hold on. No, I don't need 15. No, I just need 1. Because up here I needed 2 for this. But on this output here, yeah, okay. So no, I only need 1. I need a 14 and I need a 15. No, I'm sorry. I just need a 14. All right, so because it all depends on which number 14 comes on as far as signaling the output. So both of these will so my output here, oops, go ahead, get rid of this. So now with that being said, then I can move this back up there and feed it across this way. Because what's basically going to happen is I do a pair of switches like this, both feeding off of 14. All right. And so 14, but I need to give myself some room for this here. I can give myself a little bit more room. If I take this guy here, put it there, and if I take this dude here, put it there, I can move orange over some to there. Then I can move you, and you over some. Like so. And then we'll put you back in line with this. And then move you over 1. All right. So then we can basically have this come down into that. And this come down into that. So then, as far as switches are concerned, we're going to have one there, and one there. And actually, how about there? All right, so this switch here for yellow will take to this one here. We'll go up one, out and up, and then this guy here. All right. Now the output here, I need to do. Oh no, you know, same thing I did here. Just feed both of the switches. Like so. And then I tie this to this, making sure green needs to tie to purple. Why are you getting a circle dependency now? Here. Why are you getting a circle dependency now? That should not be causing a circle dependency. Seriously. We're going through a switch. Wait, hold on. Because this here is going into purple. Not going down that way because those two switches are blocking that. Ties into purple here. And it's going into the adding machine. Well, one, we don't use a damn bit shifter. So that shouldn't be. All right, what if we. That doesn't make any sense to me while you're saying it's circle dependency. I mean, technically speaking, the output of the register leads back to its own input. You know, if you want to go that route. So I'm not buying that bullshit. Especially on this. Because this doesn't touch an output at all. That's a damn signal switch. It doesn't pass. That passes a signal, not damn output. So that's bullshit. Well, if you like that one, then here, have another. that makes zero sense to me. Why you're saying that? Zero sense to me. I mean, if I cut this here, what happens? That makes no sense to me. Then again, like that, the whole thing about that bit shifter also, we made it, we've never used it. And well, the thing is, though, I need this because that's what's feeding this up here. So okay, so this is here, and this is here to pass on the register, and then this here passes on. So this here feeds. Oh, I'm sorry. That's the input. This here feeds the output of the RAM. See, these switches are acting technically as their own, what do you call it? One-way buffer. So I don't buy this, their notion of this loop. There's no, you know, I'm leaving that map, I'm coming back to it. There's no damn circle dependency. There isn't. And what's funny is if I kill this here, you're giving me the green light, which makes no sense to me. And what if I kill this? You give me the green light. Well, that whole thing about the zero before. So actually, yeah, I know a way of solving this. And essentially what it is 13. So essentially we need to do, okay, so I have, all right, so we're gonna do this. 13 will be push. So push to stack. 14. Actually, no, this will work. 14 will pop from stack. All right. So we'll do it this way. Because this here originally was there because you wanted it automatically to do it, but now, you know, before we wipe all this away, let's do it this way. Let me physically move this out of the way. Okay. And then break that link there. And then this here, break that link. Hold on. Okay, let's do it a different way. I'm also, something else got broken. Oh, no, it's not that it got broken. I was moving something around and that got moved. Okay. All right, so break that. Go ahead and break that. Oops. Break that. And break that. And break that. And break that. Okay. So we're going to keep this sort of intact. Because I still don't agree with it saying what it's saying. They're just going to throw this component over here for now in its entirety. All right, so the 13, this guy here, it's going to be the determining factor on whether or not we, so basically, that's going to tie into that. 13 is because on the stack, we're pushing, so this is going to tie to 13. All right. 14. We're going to do essentially a double buffer type thing here. Similar to what we did here. And that each one of these will trigger the buffer. Okay. So then all right, so the 24 I was using before is, we're going to take that out of the picture now. So it's going to go through the adding process like everything else. All right, so if I want to put a value into, I want to pop a value, as it were. If I do an immediate, so if I do 128, and let's say I want to put the value, so actually if I do a 192, which is basically forcing both values. So if I do a 10 and a 15, and then I do 13, what I should see is I should see the value 25 appear here. "13 is not triggering. Why is 13 not triggering?" Oh, because 13 is triggering on orange. That's why. I need a 13. Okay, so 13 is a 13 is an orange function because 13 is a destination function. All right, so basically this switch here needs to get moved and tapped into the orange. All right, so if I go ahead and grab this, get off that. Get off that. Break that. All right, so if I move, God damn it, get off. Just break it already. Fuck. Motherfucker, get the fuck off. Sorry. So if I put that there, tap this into that, and then bring this down to there. Go ahead and get rid of that. Go ahead and move this up some. Actually, how about we do this? Since you're yellow, just tap. Come on, damn it. Sorry. All right, so that'll give me 8. Go ahead and move you up just a hair. All right. So we get 25 there. And right now, it's what I have is going on as a loop. So, all right, so my input is only giving me 1 or 0. So and it's not going to show me anything right now because I'm not triggering it. But when I did the thing earlier, it was just giving me 1 0 1 0, which, so they want me to do, they just want me to essentially, well, in fact, this here doesn't even technically have a test. And I think the reason why is, as they said, they're leaving it on to me. Well, no, because it's, so I do have to, I guess, validate I can do a jump and then return type deal. So a jump is essentially, well, their variation of a jump. And actually, this is what we're going to do. We're going to go back to, I think was it RAM? Yeah. Yeah. So I'm going to grab all this. No, not all that. All of this. And I'm going to put this onto a notepad. All right. Now, I know one function I have here, which actually doesn't really matter. All right, so let me go. All right, so because this was okay. Actually, let me copy this down also. So my program for the RAM, it had technically jumps in it. So instead of, I guess, doing here, well, so my jump would take me to here. So so how does that work? Oops. So jump load RAM. No, so oh no, wait, no, it's we're not jumping. We are technically the call is call, and then return. So I call load. Well, I don't see call doing shit either. It's still the same color. So and return is the same color. Call one? No. All right. You know what? This is what we're going to do since when all else fails, look it up. Because something is just, if it could give me a clear, just give me something clear, I'd be fine. All right, so let me look at this here. Well, that's interesting. The guide I was previously using doesn't appear to be here anymore. All right, so I'm just gonna. That's wrong. And well, that's a bummer. I don't know where it went, but it was on here and it's not anymore. Well, that sucks. All right, well, let's do a search for this. Um, Is it case sensitive? No. So, because here's the deal is, this won't do shit for me. Because, let's do unload instead. What should happen is, should get 17 here. Yeah, because this, so this, yeah, so, I mean, I don't know what it's looking for, because I can't get the damn what you call it, jump or return to work. All right, let me see about looking at someone else's. All right, where was this guy at in his thing? Okay, so he's, sorry. So he has jump as a. So you have to define. You have to define. You have to define jump as. It can't just be jump. It's got to be. Let me take a look at this one here. Oh, you know what? I just noticed something. They've got a Discord. Well, let's go tap into Discord and see what we see on there. Because maybe that'll make more sense to me. All right, so puzzle help. All right, so let's search for function. Should. No, that's not really really telling me anything. Well, let me scroll through this and see if I can find anything here. There's all right, so there's not really anything in there. And I mean, okay, so one thing they're saying is, and just double check here, I am on leg. All right, so well, because here's the thing, and this may be the end of this fun. I'm going to just say, screw it. Yeah, you can trust me. Because these here, let's see what we got here. Because, see, intern type of planning name, fortunately forgot to capitalize each name, input to this level, ASCII, each name. All right, so what exactly do you want me to do then? The input in this level represents the characters, such as class name coded in ASCII. See the manual. Each name is separated by space. So essentially, you want me to send through or store in memory the planet names? Is that capitalize each planet name? And then what? Output the planet one by one? I mean, that's fairly simple to do in so the input in this level represents, okay, so you give me an input in ASCII. Each name is separated by a space which has numeric value 32. Replace the first letter in each word with its uppercase counterpart. All right, so okay, I get what's going on here. Sort of. So Essentially, this is going to be the RAM load. And what I mean by that is, so let me just see here. Okay. Well, that's not what I was expecting. I was expecting, you know, Earthling planets, not this. All right, so we know the very first. Okay, so let's do this for starters. This here is basically now the one thing I don't have to worry about on this shit, and we'll do it just because we're gonna make this we're just gonna max this out for the time being. So this here is filling up the thing, and every 30 once you get to 32, you need to do an evaluation. And you know, I think what you're supposed to do also is each time this hits, so you know, so the stack register here would basically take the beginning of each planet name. So you would so at first, I mean, you're gonna have 0 because 0 is gonna be the first, and then when you hit 32 here, it would take the next one, put it in the stack, and then here, put in the stack, so that once the planet names are filled, you know what? And this was a good game. At this point now, unfortunately, these levels here, I don't see us doing any of these. This is asking me to do stuff that in like assembly code and stuff like that I'm really not familiar with. So what we're going to do here is we're going to do a stream switch, and we're going to go ahead and start our next game. So we'll be back in a few moments, messing around with it's Opus Magnus or something like that.